Okay, today we're going to be talking about the transformation dilations. Dilation is where we're going to reduce or enlarge a figure by a determined amount. A dilation is the image produced by enlarging or reducing a figure by a scale factor. So it's the scale factor that's going to determine how large or how small your figure is going to get. A scale factor is the ratio of the lengths of two corresponding sides of two similar figures. So if you recall when we did similar figures when we were doing proportions, we find the two sides that are the same on each of the figures, and those are our two corresponding sides. To find the scale factor, we're going to take the side of the new figure divided by the side of the original figure. So sometimes we just think of it as new over original. Oftentimes I ask students if they like to find scale factor, and most likely the answer is no, N over O. So an enlargement is an image that is larger than the original figure, and this scale factor is always greater than 1. So if we're getting larger, our scale factor has to be greater than 1. Now reduction is an image that is smaller than the original figure, and the scale factor is always less than 1. So this is especially important when it comes to taking assessments and you have multiple choice answers. If you can recall that in an enlargement you're getting larger, so the number has to be larger than 1, and in reduction you're getting smaller, and so your scale factor has to be smaller than 1. So let's look at two things, finding the scale factor and then how we use the scale factor. So here are two similar figures, two triangles. The original figure has a base length of 8 and the new figure has a base length of 2. So the first thing you want to notice is that this is a reduction. It's getting smaller. That will help you predetermine whether or not you've done your scale factor right. To find the scale factor, we're going to take the new side over the original side. Well, the new side has a length of 2, and the original side has a length of 8. So we have 2 over 8, and 2 over 8 reduces to 1/4. And now you might want to remind yourself, it's a reduction, it's getting smaller, my scale factor must be less than 1, and 1/4 is definitely less than 1. So in all likelihood, we've done this correctly. So now we're going to look at an enlargement, the two trapezoids. We have an original base length of 3 and a new base length of 18. We know it's an enlargement sheerly by the fact that it's getting larger. Our base lengths are getting larger. So to determine the scale factor, we're going to take the new side, which is 18, over the original side, which is 3, and then we're going to simplify our fraction. 18 over 3 is equivalent to 6 over 1. Now you don't necessarily have to write 6 over 1. 6, the whole number 6 would be fine. So now how do we use the scale factor? And I will say scale factor shouldn't make you cry. All you have to do is multiply. So if I give you a rectangle and I need you to dilate the rectangle by a scale factor of 3, the first thing I want you to think about is that the scale factor is larger than 1. The scale factor is 3. So is this going to be a reduction or an enlargement? Well, hopefully you remember that if the scale factor is greater than 1, it's going to be an enlargement. So we expect our new rectangle to get larger. To find the dimensions of the new rectangle, the length and the width, we simply have to multiply. We take our original figure and multiply by our scale factor to get our new figure. So 3 times 3 is 9, and 5 times 3 is 15. We multiply the corresponding sides by the scale factor to get the new figure. We're going to try it again, dilating the triangle by a scale factor of 1/2. So again, the first thing you would want to ask yourself is this going to get larger or smaller? Well, the scale factor is less than 1, so we should see a reduction. Our figure should get smaller. So our corresponding triangle is got dimensions 2, 3. Well, 1/2 of 4 is 2, and 1/2 of 6 is 3. So multiplying 4 by 1/2 gave us 2, and 6 by 1/2 gave us 3. So the scale factor, let's recall, we're doing the new side over the original. And I want you to see it going in two different directions. So if we start from the left and go to the right of our trapezoid, our figure, our original figure to our new figure, is getting smaller. So we expect our scale factor to be less than 1. Our new figure is 8 over the original 12. That reduces to 2 over 3. And 2 over 3, 2/3, is less than 1. So we have a reduction. Now what if we were to go the other direction? What if we were to go to from the trapezoid, the new trapezoid, to the original trapezoid? If I was going from the trapezoid that is 8 to a trapezoid that is 12, I would expect it to be an enlargement. The 12 over the 8 reduces to 3 over 2, which is larger than 1, to give me the enlargement. Now what I'd like to draw your attention to is the two scale factors. The reduction was 2 over 3, and the enlargement was 3 over 2. Let's see if that pattern continues. So on my triangles, I'm going for an original of 6 to a new of 15, so I better be an enlargement. The new side over the original, 15 over 6, reduces to 5 over 2, and 5 over 2 is greater than 1, which is an enlargement. Now if I went the other direction, from the enlargement to the smaller one, to the original, new to original, then I would get a reduction. Because if I went the other direction, then the 6 would be my original, the 6 would be my new, 15 the original, and reducing, you have 2 over 5, which is less than 1, which is a reduction. So again, let's just compare our scale factors. When I went in the enlargement from left to right, the scale factor was 5 over 2. But when I reversed the direction and went from the new to the original, my scale factor was 2 over 5. Can you see a similarity yet? We're going to do one more. So my circles, going from left to right, I'm getting smaller from 4 to 2. So my new side is 2, my original is 4, the scale factor is 1/2, that's less than 1, which is a reduction. If I went the other direction, I'd have 4 over 2, which is 2 over 1. 2 over 1 is greater than 1, I've got an enlargement. So the thing I want to draw your attention to right now, because if you recognize this, it can be very helpful. 2 over 3, 3 over 2. 5 over 2, 2 over 5, and 1 over 2, and 2 over 1. So I want you to notice that when you go the other direction, you take the inverse or you flip your fraction to get the new scale factor. Okay, we're going to move on here into our dilation notes. So now if I give you a triangle JKL and it's going to be dilated by a scale factor of 2, using the origin as the center of dilation, and point J is not moved, what will be the coordinates of the dilation triangle JPR? Well, the first thing you have to do is let's find our coordinates for J, K, and L. Now that we have our coordinates for J, K, and L, let's see if we can just apply the scale factor. So the scale factor is 2. Now remember, scale factor shouldn't make you cry. All you have to do is multiply. You can determine the side lengths and multiply each of the side lengths by 2. So the side length JL is 4 units long. So my new side length should be 8 units long, twice as big. But instead, I'm going to go ahead and apply the scale factor to the ordered pairs. And since I just need to multiply, my J is going to stay the same, but my P is going to be twice as big as my K. So 4 times 2 is 8, and 3 times 2 is 6, and that's going to give me the coordinate 8, 6. The same thing with my L. 4, 0 is going to be twice as big, so 4 times 2 is 8, and 0 times 2 is 0, so I have the R is the coordinate 8, 0. And then by finding the coordinates, you're just plotting those points. You join them together and you have your new triangle. So here we're looking at two different rectangles. And it says rectangle A prime, B prime, C prime, D prime is a dilation of rectangle ABCD. So the first thing you have to determine is which one's the new and which one's the original. Well, hopefully you remember that your A prime, B prime, C prime, D prime, that the fact that it has primes on there means that that's the new figure. So we've labeled the sides of each of the rectangles with the dimensions. And it asks us, is a dilation a reduction or an enlargement? Well, if the A prime, B prime, C prime, D prime is the new figure, then we should be able to say it's a reduction. It's definitely getting smaller. The side length has gone from 16 to 18 or from 6 to 3. So how do we know? We know because it gets smaller. Is the scale factor going to be greater than or less than 1? Well, it's going to be less than 1 because it's a reduction. And now they want us to determine the scale factor. Well, remember, scale factor is just the new side over the original, and it doesn't matter which side you pick. But if I'm going to pick the side 3, I have to use the corresponding side 6. So just as a reminder about corresponding sides, and sometimes I think I've told you before, it's helpful to use some kind of color. If I'm going to use this corresponding side 3, I have to use the same corresponding side in the other figure to get 6. So the scale factor was 1/2. And does 1/2 make sense? 1/2 is less than 1 and it's a reduction. We're going to try it again. Triangle A prime, B prime, C prime is a dilation of triangle ABC. So the first thing they ask us to do is to label the sides of each of the triangles with their dimensions. Now be careful when you're counting up the sides, and sometimes I have students write little X's underneath the side length so that they can count the entire squares. Sometimes they make the mistake of counting the points and you miscount. So if you put the little X's underneath the side length, now you don't have to do this, it's just a suggestion. You can put and then you can count up how many X's you have to see that you have 14 over the 7. So, is the dilation a reduction or an enlargement? Well, let's remember which one is the new figure and which one is the original. It's an enlargement because the A prime, B prime, C prime is the new figure. How do I know? Because it gets bigger. Is the scale factor going to be greater or less than 1? And it's going to be greater than 1 because it's an enlargement. And now they want us to determine the scale factor. So just remembering, take the new side over the original. And in this time, I took not the bottom, the base, but I took the sides. It doesn't matter. The 12 over the 6 gives me a scale factor of 2 over 1. I could have taken the 14 over the 7 and gotten the same scale factor. So now I have 3 triangles. It says triangle LMN is a dilation of triangle ABC. So this time we don't have the little primes to tell us which one is the new and which one's the original. So the first thing you've got to do is identify the triangle LMN is a dilation of triangle ABC. So LMN is our new triangle and ABC is the original. So simply looking at it is a dilation, a reduction, or an enlargement. And hopefully you can see that it's a reduction. It's definitely getting smaller. To find this scale factor, we're going to take the new side over the original. So I'm going to look at, doesn't matter whether I look at the length of LM or the length of NM, you're still going to get 1 over 2, so your scale factor is going to be 1/2. Now triangle XYZ is the dilation of ABC. And is this dilation a reduction or an enlargement? Well, hopefully you can see that XYZ is the new side, ABC is the original, and you're getting larger, so you're an enlargement. To determine the scale factor here, once again it's the new side over the original, 2 over 1, so we have a scale factor of 2. So here we're going to look at if we were going to enlarge a picture. We have a square here, a 4 by 4 square, and it says we're going to enlarge the dimensions of the photo, first of all by a scale factor of 2, and then we're going to reduce the photo by a scale factor of 1/2. So the first thing I want to do is I want to go ahead and find the coordinates for my ABCD. So A is 0, 0, B is 0, 4, C is 4, 4, and D is 4, 0. Now, the first thing they want us to do is to enlarge the picture to be twice the original size. So I'm going to remember that if I'm making something twice as big, that means my scale factor is 2. And once again, scale factor shouldn't make you cry. All you have to do is multiply. So instead of plotting the points first of all, I'm going to apply it to my ordered pairs. Well, 0, 0, 0 times 2 is 0, and 0 times 2 is 0, so my A coordinate is going to stay the same. It's going to be my fixed point of dilation. Now my B coordinate is going to change. Instead of being 0, 4, because I'm multiplying it by 2, I'm going to get 0, 8. My C coordinate is going to change from 4, 4 to 8, 8. 4 times 2 is 8. And my D coordinate is going to change from 4, 0 to 8, 0. So let's think about what we did to get these new coordinates. Each of the x and each of the y's were multiplied by 2. So my coordinates, the rule here is 2x, 2y. 2 times the x's and 2 times the y, which means that my enlarged picture is no longer 4 by 4, but is actually 8 by 8. Now let's see what that looks like. If I plot the new points, my x, y, and z, and join them together, I get a square that is twice the size of the original square. Now if I was going to reduce this square by 1/2, once again you're just going to multiply. Your A coordinate's going to stay the same because 0 times anything is still just 0. Your B coordinate is going to go from 0, 4 to 0, 2 because 1/2 of 4 is 2. The C coordinate went from 4, 4 to 2, 2 because 1/2 of 4 is 2, and you're going to do that on both the x and the y. And then your D coordinate is going to become 2, 0 because 1/2 of 4 is 2 and 1/2 of 0 is still 0. So we have an x and a y coordinate, and each of these coordinates were multiplied by 1/2. We took 1/2 of our x's to come up with our new x's, and 1/2 of our y's to come up with our new y's. So from our original picture, which was 4 by 4, we should come up with a new picture that is 2 by 2. And if we come in here and plot E, F, and G, you'll see we have a new picture, a new square that is 2 by 2. So you can do it by multiplying the length of the side, plotting the points first, and then determining the new coordinates. Or you can take the coordinates and apply the scale factor directly to the coordinates and then plot the points. Either way will get you to the right answer. So contrasting the two pictures, what happened to the x-coordinates? Well, they doubled. We multiplied them by 2. This is the enlarged picture. What happened to the y-coordinates? Well, the same thing. What happens to the x-coordinates has to happen to the y-coordinates. And so the rule that describes the enlargement, 2 times x and 2 times y, which algebraically we just write 2x, 2y. Contrast the original picture with the reduced picture. Well, the x-coordinates became smaller by half, and so did the y-coordinates. And so what's the rule that describes the reduction? We have half of the x's and half of the y's, which we can just write as 1/2 x, 1/2 y. The 1/2 with the variable beside it tells me I'm going to multiply 1/2 times whatever my x value is. So here we have another one. Triangle RST was dilated to form triangle LMN. And it says which number best represents the scale factor used to create triangle RST. So you first of all want to remember which one is the new one and which one is the original. RST was dilated, so RST you can think of was changed to form LMN. So which number best represents the scale factor? Well, if RST was changed to give you LMN, the first thing I want to know is it a reduction or an enlargement? And hopefully you can look, either count the sides, or even just by looking at the two triangles, you can see that it is an enlargement. The fact that it's an enlargement tells me that my scale factor has to be larger than 1. So C is definitely not my answer. 2/3 is less than 1. And now I can determine what my scale factor is by taking my new side over the original and reducing. 18/12 is 3/2. And I have my answer. So we have another one here. Pentagon ABCDE was dilated to form pentagon JKLMN. So ABCDE was changed, if you want to cross off the word dilated and put the word changed there, to form the new pentagon. So the first thing I want to say is it a dilation, a reduction, or an enlargement? You should be able to just look at the two figures and say, well, it has to be a reduction. How do we know? It gets smaller. Is this scale factor going to be greater than or less than 1? You should realize it's going to be less than 1 because it's a reduction. And now we have to determine this scale factor. Well, now we have to count up our sides. And you cannot count up the sides that are on an angle. You can only count up those bases. So to determine the scale factor, we have the new side over the original and we reduce. So remember, scale factor shouldn't make you cry. All you got to do is multiply. The new side over the original will give you the scale factor. Or if you have the scale factor, you simply multiply it by the corresponding sides to get your new figure.